Let me show you how to be a good Bayesian.
Today, I'm joined by Matt Penn, a football data scientist for the Italian football club Como 1907, pardon my Italian, helping them achieve promotion to Serie A last season for the first time in 20 years. With a background in mathematics from Oxford and a passion for football, Matt now applies statistical modeling to help clubs make smarter, data-driven decisions. In this episode, Matt walks us through his journey into football analytics, one that started during the lockdown and quickly evolved into a full-time career. We discuss the role of Bayesian methods in football, particularly when working with limited data, and the challenges of communicating statistical insights to coaches and decision makers. Matt also shares his experience in building a data team within a football club, highlighting the importance of bridging the gap between analytics and coaching. We dive deep into the world of player recruitment and transfer strategies, exploring how biases in traditional football statistics can distort player evaluations and how tracking data is transforming our understanding of performance. From expected passes to the differences between men's and women's football, this conversation is packed with insights into the evolving landscape of sports analytics. This is Learning Bayesian Statistics, episode 128, recorded November 19, 2024.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence.
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is la place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. And if today's discussion sparked ideas for your business, well, our team at PIMC Labs can help bring them to life. Check us out at pimc-labs.com. Matt Penn, welcome to Learning Bayesian Statistics.
Thank you.
No, thank you for taking the time, and a big thank you to Desi Ivanova, a common friend of ours. Desi recommended me to interview you on the show because she knows I love stats and sports. So she was like, "Oh, you gotta meet Matt." So but yeah, for people who want to hear more actually about Desi, I just had her on the show, episode 117, and we dove. I think you say we dove in English, right?
I think so.
Okay.
Yeah.
Okay, so we dove into the fascinating work Desi is doing on Bayesian experimental design. So yeah, definitely encourage you guys to check this one out. I'll put it in the show notes because that's definitely a great one. I had great feedback about that one, Desi. So thanks a lot, and well, lots of pressure for us today, Matt. Let's try and keep
It's a tough act to follow.
Yeah, I know, but like let's try. So actually, can you share your journey with us? Because I like your path, because you studied math at Oxford, but now you work in football analytics or soccer analytics for our American friends. So yeah, I'm curious how did that happen?
Yeah, so like you said, I did an undergrad and master's in maths at the University of Oxford, and then went on to do a PhD in statistics. And really, certainly going into that, the plan was not to go into football. I thought I'd probably go become an academic or work in research in some other way. But it was during lockdown. It was kind of winter 2021. It was cold outside and we were stuck inside. And I was sat playing the video game Football Manager. I'm hoping at least some of the people listening in have played that too. If not, I would thoroughly recommend, although it's a dangerous one to spend too much time on. but yeah, so doing that and just kind of thinking, oh, I actually probably have the skills to do this for real now, or at least to do some of it for real, to kind of, curate some of this data myself, to start building models, and to start having an effect on how clubs sign players and how they line up. And so I just sent out a load of random emails to clubs in Oxfordshire, which is where I was living at the time, just saying, oh, would you like anyone to come do some free data analysis for you? I kind of forgot about it after that. Like, life went on, and then about a month later, someone from Oxford City Football Club, which is a semi-professional football team in Oxfordshire, got back to me, and they were like, yeah, we'd love to have you on board. So yeah, it just kind of, it started from there. Really, I was kind of useless for the first year, to be perfectly honest, just trying to work out. I think I came in thinking, oh, I'm going to solve everything. I'm better than all of these other people, and that turned out to be very much not the case. All of these people really knew what they were doing, and I did not. But yeah, they were very patient with me. A guy called Wilkie from Oxford City in particular, and yeah, just kind of snowballed from there, really. So worked for them for a few years. Also did some work for Solihull Moors and Oxford United while I was doing my PhD. And then when that finished, moved to FC Como, who at the time were second division in Italy, now promoted to the first division. And yeah, been working there since.
This is really cool. Yeah, I love it. And were you already, like, have you always been a football fan? Do you have a team you root for?
Yeah, very much grew up kind of the classic, I don't know, I was probably a classic 7-year-old boy obsessed with football. Played a lot of football when I was a child, although deeply unsuccessfully. I always shudder to think what would happen if my data ever appeared on any of our data sources. But yeah, grew up supporting Bolton Wanderers, who were a really trendy English football team for like about a year and a half, and I made a terrible mistake to support them, and it's been all downhill since then.
Yeah.
But, and yeah, kind of, always following football, always playing things like Football Manager. So it's been a real joy to be able to do that in my kind of 9 to 5 as well, working for Como.
Yeah, I guess. And so yeah, we've been the same 7-year-old, So, and I've made the same mistake of. So when I was 5, it was 1995, and PSG won its first and I think only until now European Cup, like the previous Champions League. I don't remember the name in English. And so of course they were everywhere on TV in France, and my favorite color was blue, so it became my team. And that was a big mistake because now I have to root for them. It's absolutely terrible. So
I know. Yeah. The temptation is so there to change, but I just couldn't not support Bolton.
Oh yeah,
You're the same. Like.
Oh yeah, believe me, I tried. Being like terrible.
It's not the same, is it?
Yeah. This is awesome. I have amazing data, and it's about professional athletes, and I get to do models about how the performance. Absolutely incredible. So really grateful for that. And actually, I'm curious because I, of course, use Bayesian stats a lot in my work and in everything, even in my life. What about you? Are you using any Bayesian stats at work? And even more generally, do you remember when you were first introduced to Bayesian stats?
Yeah, I guess maybe I'll start with when I was first introduced, and then, spoiler alert, I do use it quite a lot at work. I remember it was in our like second year undergrad stats course, and it was just this little section at the end of the course. It had all been very frequentist up to that point, and then we had like 3 lectures on Bayesian stats. And I remember walking out the first one going like, "Mate, this is nonsense. Like, you don't know the prior. What's going on? I would never use this." And then slowly over time realised that maybe my initial reaction as a kind of know-it-all second year undergrad was not necessarily correct. And so yeah, like, have really come to appreciate how useful it is. I think particularly in a football context, the places where certainly it's the most powerful are the places where you don't have very much data. So when you're trying to model something, you come up with a parametric model and you've not got much to fit to it. So for example, kind of modelling international football results is a really good example of that. You've got kind of over the course of 4 years, which is maybe as much relevant data as you can get. You've got maybe, I don't know, 30, 40 games tops for each team. And so trying to train a kind of traditional, maybe it's not traditional, but like an XG boost model or something, like you just end up overfitting massively. Whereas Bayesian stats really helps you kind of know what you don't know, I guess.
Yeah, I couldn't put it better. I mean, even when you have a lot of data, so yeah, I know a bit about football data, and I know also about baseball data because that's my job. And in baseball, we have a ton of data. It's absolutely incredible. But you have a lot of data in aggregate. Doesn't mean you have a lot of data about each and every player. Yeah. And so, I mean, even if you have millions of rows, doesn't mean you have millions of rows about each player. And actually, Bayesian stats are still super useful there because, well, there's a lot of players you don't know a lot about, and you want to make inferences about what they could do and are able to do. Well, here, that's super helpful too.
Yeah, definitely. And like in a football context, it's those kind of rare actions which kind of fall into that category. So something like looking at players passing, you've got lots of data on them. Like a top player will do 100 passes a game. That's kind of enough to do whatever you want. But when you start to look at something like shooting, particularly maybe from a goalkeeper, like saving shots, you're probably only facing like 5 shots a game that are on target. So it's, in those scenarios where, again, it becomes really important.
Yeah, great point. I've been working lately for an open source or project, like that, just for fun with football data, and we're looking at scoring rates, and scoring rates are so low. It's just so hard to score a goal, and it's so low that using a Poisson likelihood, for instance, which you think that would be the likelihood you want, right? Because that's already rare events for the Poisson. The Poisson is actually too heavy on the right tail, right? So it's going to have too much probability mass around 2, 3, 4 goals, which are actually very rare from an individual perspective, right? It's actually very rare that one given player scores a goal, and then more than one goal, it's even more rare. And the Poisson is just, it puts too much emphasis on the 2, 3 plus goals. And since you don't have enough data to inform that these scenarios are actually very improbable, then if you don't or change the likelihood or inform the prior about that, then the model will be happily saying, oh yeah, but there is a lot of uncertainty. That player, maybe he'll end up scoring 5 goals in the next game. No, he won't. Even if that's messy, that's very rare. So, that's really domain knowledge that you want to use, or even like really statistical knowledge here, even.
Yeah, definitely.
And I'm wondering, like for you, for instance, for you in football in general, what is your main obstacle or pain point when you're using a Bayesian model?
Yeah, I guess a lot of, to be fair, this is in some sense a more general obstacle. It's very easy to come up with something you might want to model about a game. You might want to model like, I don't know, which of the opposition players is going to make the most passes in your final third or something, like close to your goal. The difficulty with all football models is how do you actually then apply that into the game? Like, it's all very well, if we're playing Man City, I can go to the coaches and say, that Erling Haaland guy, he's quite good. But they can't actually use that. And so it's kind of, you're always having to balance kind of interesting data to model, but also using the insight from the coaches and the people you're working with to try and go, okay, how can we, like, what possible things could we do in this game? Like, what possible strategies could we employ? And then how can we kind of model whether or not they'll solve this problem? So kind of making sure that what you're doing is really, really applicable is a real challenge. So basically all of my work is in Python. So I guess that makes me not a real coder, but it does the job.
I do everything in Python, and I'm an open source developer in Python. So you're like, you're welcome here.
That's good. because I was meant to code some JavaScript this week for an app, and that did not go well. So I'm very happy.
Oh my God.
Very happy sticking with Python.
Oh yeah. I feel your pain.
But yeah, and then within that, kind of a lot of the stuff, I don't know, I maybe have a bad tendency to kind of often try and code everything custom myself. So like if we're doing a MCMC loop, for example, obviously there are lots of great packages out there to do that in Python, but I'd always have the temptation to do it myself, and then kind of you'll be able to fit in a few custom speed ups and things like that in the process. But yeah, I think does that maybe answer your question? I'm not 100% sure.
Yeah. And also, I'm curious, like, do you use any package to write the models? Like, are you using PyMC or using NumPyro?
Yeah, so again, the models themselves are generally just kind of Python scripts, maybe wrapped up in Number or something like that to precompile and speed it up.
Okay.
And then just kind of, but fairly standard Python.
Okay, yeah. Then so you might want to look at PyMC because we have the Number backend.
Okay, nice.
So you'll be able to run your models in Number. If you use NumPy under the hood, this is using Number, or you can even use JAX if you have a GPU or if you need one.
Okay, great.
Yeah. So yeah, lots of cool stuff on that front. So yeah, like if
cool.
you need any tips on how to get started with that, well, feel free to contact me in private, and I'll be happy to hook you up.
Oh, that's very kind. Thank you.
Okay. And something I'm also curious is you talked about like the models need to be actionable, right? So whoever you're developing the model with, you want to understand how they are going to consume the model.
Yeah.
So I'm curious what your experience is, right now at Como, but also your previous clubs. What was your experience talking to the coaches, to the teams? Did you find that some parts were actually easier than you expected, some parts harder? What was your experience of that, making that translation between the technical side and the sports side?
Yeah, I think it's definitely a skill I've had to develop over the last few years. I've been very lucky to kind of work with clubs where the coaches are very much, they want to be very data driven. They're very much kind of evidence based in their decisions, and that's been a really good thing because that's not guaranteed in the football world from stories from other people I've worked with. But yeah, in terms of kind of communicating, I think really a lot of it is giving the coaches the tools to kind of both ask the questions that they want to know the answer to, and also just kind of be aware of what you could do. Because I think the first few times I had meetings with coaches, I'd be like, oh, what do you want me to do? We've got lots of data, and that would be it. And then as a coach who's kind of, has a lot of football knowledge in their head, but has never really hasn't got the same stats experience. You're asking them to do, you're essentially asking them to plan a stats project, which is very much not their skill set, and not the best use of their time.
Yeah.
So I think a lot of it is kind of being able to very quickly come up with demos of what you might want to show, like even if it's kind of, you've horrendously hard-coded something in a notebook, just to kind of show them. It's kind of, being able to kind of sit in the meetings that they do pre-match and post-match with the players. That gives you a really good insight into kind of the sort of things that they think are important, the sort of things that are coming up in these briefings. And then that gives you kind of something to bounce off and go, oh, okay, I've seen that you've done this. Maybe I could do something related to this work you've done on their high press or something like that. And then you can start building that relationship where you're bouncing off each other.
It's extremely valuable. Like basically what I try to do is that.
Yeah, it would be so easy to just like sit in a room for a year and build really cool stuff on football, and I'd have a great time, but no one would use it. And so it's important to kind of remember the people who are like your consumers essentially.
Exactly. And that also helps you a lot to prioritize, right? Because
Yeah.
otherwise, you can do a model about anything. It's like just basically, kind of what you were telling the coaches. Like, I definitely could do the same thing where like I go see the coach or the GM and I'm like, okay, what are you curious about? What do you want to know? I can build a model about anything, so just ask. But then like that's precisely the problem, because you have to prioritize what's the most useful to them, because otherwise you can end up having an awesome model, but if they don't use it, that's not very good, So
Yeah.
that
And I
helps
think
you a
with
lot.
I think with sports analytics being so new as well, it's not the case that you've got like a set 10 things you want before each game and you're just kind of iterating on them and making those slightly better at predicting or whatever. Like, you're genuinely you're coming up with that list of 10 things that you want. And so, I think that makes it a really interesting time to work in sports at the minute, but also a challenge, because you've got to work out what's a good thing to be researching, like you say.
Yeah, definitely. And also, it depends on the size of your data team, right? As the club, because if you're just a handful of people, then you have to be very good at prioritizing. Okay, we really want that right now. That stuff would be awesome, but that's later down the road, because we need more time to develop that, or more people, and we don't have more people. If you're a huge team like the big MLB teams here, they have 20, 30 research analysts, so they can do so many things in parallel. It's like having a GPU, basically. It makes your model run faster, right? But it doesn't mean your model is going to be better, but you can try so many more things than if you're just 2, 3, 4 people. But in this case, you have to prioritize more. And so, this is extremely, extremely important. I'm curious, actually, how does that work for you with the Como team? Like, because you were telling me before the show that actually the team is based in London. The club obviously is Italian. Obviously, people know about Como Lake. If you don't, try and go there at some point. Maybe not in the summer because it's just too many people. But that's an amazing day. Like, if you're in Milan, already Milan is a great city to visit. To live, that's even better. I really like Milan. And then you can take a day. You take the train. You go to Como and you just enjoy, because that's amazing. But the team, so the team is there, but the data team is actually in London. Am I right?
Yeah, I remember when I first got offered this job, I shouted up the stairs to my wife, "We're moving to Como," in this hugely exciting voice, and then a few hours later discovered that was not indeed the case, which is a bit of a shame. But Oxford is pretty too, and I get to go out every now and again. But so it's a pretty new team. So I joined kind of at the start of this year, when it was just me and one other guy, kind of on the data side, and then we've been hiring this year. We're always open to interesting people. If anyone's listening to this and they think, "Ooh, come work for Como," so I think we now have. It's difficult to remember. I think we now have maybe about 9 people, something like that, and a mixture of kind of. We've got a few people on the kind of data engineering side who are massively helpful, and I'm very grateful to have them. And then some people on the kind of data science, data research side as well. It's a really good team to be working in, and kind of we have a very good kind of like, I don't know what the word for it is, like back end, like data warehouse type thing. Certainly compared to clubs I've worked for in the past, where it's just been me and everything's just stored in horrible local files and I'm scrambling around trying to make things work.
Yeah, but that makes your life way easier, right?
100%. I'm not sure I could live without Google BigQuery now. That's
I mean, it's like the foundation of what you can do, basically. Like, if you don't have that, then you can hire scientists, but they're not going to be the most efficient they could be, because basically it's going to be very hard to get the raw material. It's like basically. So it's going to sound very pretentious, but I think it's a good analogy. It's like contracting Michelangelo to have a sculpture and then having him just come to where he has to do the sculpture with all the marble and so on. Like, no, you want the marble to be all ready for him, and like that's a great marble. He can just do the work, and boom, because you have like other people are much better than him to source the marble or something like that, right? So that's basically what you want, because otherwise, without the good marble, you're gonna lose time, and Michelangelo costs a lot, I guess. So I don't know.
Yeah, no, 100%, and like it's definitely something I've learned with this kind of being my first proper role, is how important that stuff is.
Yeah, no, for sure. Actually, I'm curious now. So first, that's awesome. Like 9 people doing data stuff. That's really cool, and I'm pretty sure that makes you guys in the top 1%, I would say, of teams using data in Europe, and not only in football. I guess in most professional sports in Europe, because I don't know a lot of teams who are that developed doing that in Europe. So for that's awesome. And second, I'm wondering then, what does a typical day look like for you at work, and what are some of the key responsibilities in your role?
Yeah, so I guess for me in particular, quite a lot of my focus, certainly in the last few months, has shifted towards player recruitment, which I guess is the side of football data analysis we haven't quite touched on yet, but particularly at the minute, the January transfer window, where you get to buy and sell players, is coming up increasingly fast. We're kind of submitting all of our lists of recommendations, and then they have to go through all of the phases of being scouted and discovering whether or not we can actually afford them, discovering whether or not they actually want to come, and all of those things. So a lot of it will be, I don't know, there's models I'm working on at the minute that go towards that, and so it will be kind of, maybe we're adding a new feature to it, taking in some new data, and then kind of retraining those, seeing what effect they have on the lists of players that we have, see kind of, we're at the stage now where we've kind of got a relatively short list of targets for each position, and so we're able to kind of do a bit more in-depth analysis of those guys and see, okay, what do we forecast if they join us? And then at the same time, kind of responding to, as a team, we absorb quite a lot of ad hoc requests from the coaching staff. Being able to kind of respond to those, whether it's kind of, I don't know, we've got a particular opponent coming up and we want to look at a particular thing about their style, or we need a particular report on, like, maybe someone's played international matches and we need to kind of look at how they did physically in those games or something. It can be a whole range of things. It's not an industry where you can very easily plan ahead, like 2 weeks on Wednesday I will spend the whole day doing this and nothing else. That's not really possible, but that keeps it fun.
Yeah, for sure. I'm wondering, actually, a question I have for you that I often hear, like, kind of widespread belief in football is that the winter transfer window is not very useful and nothing happens. Is that something you see in the data? Yeah,
I mean, certainly, I think the lower down the pyramid you go, and that's kind of been where a lot of my experience has been up till this year. Clubs very much do use the winter transfer window. So where I started at Oxford City and we were semi-pro, we would sign players actually all the way through the season. There weren't specific transfer windows. But even somewhere like Como, like you still want to be on the lookout for players. It's particularly important for players coming to the end of their contract. So if you've got a deal that expires in the summer, when generally most player contracts do end, then the January before that is kind of a good opportunity to pick up those players at a reasonably cheap price, and so that's an important thing to look at. You've also got players who maybe joined a club and then aren't playing, or got replaced towards the end of the summer transfer window and aren't playing, and so there are opportunities to pick up good players. The very good players will come with a premium in January though, because clubs don't want to sell them mid-season.
Yeah, so it's kind of like that was my prior, that basically it's more useful for lower ranking clubs than big clubs, right?
Yeah, exactly. And I mean, you've always, like, it depends kind of what people might cost more, but you might need them more in January as well. And so you've just got to kind of weigh up, like, you've got a better idea of how your season's going. you can make a better assessment of, if we sign such and such a player, maybe we expect, if your chance of relegation changes from 70% to 10%, then that's really worth it, and that's something you can make a slightly more accurate assessment of in January. Although that would maybe be quite a player who decreased your relegation chances by that much.
I mean, and it's also, I mean, that's often like that in football, right? The richest clubs often have their way anyways. Like when they really need someone.
Exactly. But yes, I'd be shocked. With no data behind it, I'd be shocked if they didn't sign a few players, like you say.
Yeah, same. Something I'm curious about is if you know any common biases in your football data, and how do you adjust for them in your analysis?
Yeah, so I think there's quite a lot of biases in terms of, and particularly on the recruitment side, in terms of using the kind of traditional stats that you use to assess a football game. So possibly the canonical example of this is something like a pass completion rate for a player. So that's kind of long been used to kind of, if you're trying to play a passing game, you want to bring in players with high pass completion rates, and that's not untrue. But it's also so dependent on the kind of difficulty of the passes which they're attempting. A player who kind of plays in defensive midfield, taps the ball about a little bit, will have a high pass completion rate. A player looking to play really aggressive balls will have a much lower one. And so one of the places that kind of, statistical modelling can help you there is you can come up with an expected passes score. I guess probably a lot of people listening are maybe familiar with expected goals. And expected passes is just the same as that. It's, for each pass, what do we think the probability of this being completed is? And as we increasingly get more data in football, like, our models for expected passes can become increasingly good. So kind of, 5-6 years ago, before you had tracking data and you just had very granular event data of, there was this player here and he tried this pass to this other player on the other side of the pitch, you can make a kind of model, like if it's a long pass, if it's a forward pass, those things make the pass more difficult. But now, like, we have data on kind of where every player is across the whole pitch, and increasingly even what direction they were facing, and maybe where their elbow was, if you want to try and use that. And so that kind of lets you, make a really unbiased assessment of how good a player is at passing, not taking into account kind of the kinds of passes that they're trying. And this is something that kind of really early on, I think, is still one of my favourite football analytics stories. Is when I was at Oxford City, we had one of these expected passes models. We were playing against the team who at the time had won, I think, 11 out of 11 in the league, the mighty Ebbsfleet United. And all of their team have really high pass completion rates. But we noticed that their goalkeeper actually was massively underperforming his expected passes, because he was just playing really simple passes to the centre-backs. Whenever he went long, he gave the ball away. And so the strategy for that match was, well, great, we should try and press the goalkeeper, which we did. Kind of took away his passing options. That worked really well, to the point where the goalkeeper actually came out at half-time and practiced kicking long, because he was being forced to, and that was so out of his comfort zone. And so, that's kind of a really good example of looking beyond just the basic statistics and using modelling to get some useful conclusions out, and a point at home to Ebbsfleet.
Yeah. That's awesome. I really like that example for sure. And actually, do you have another example of a particularly insightful finding that helped you assess player strength and weaknesses using data, which is something I guess you do a lot, especially for transfer recommendations?
Yeah, definitely. Obviously, there's a limit of exactly what I can give away on a podcast, sadly.
Yeah,
but think of an example. I think one really interesting study which I did while I was still at uni, and this is kind of not quite so much on a player level, but it was assessing, kind of comparing men's and women's football. So I did a paper just before the Women's World Cup in 2023, and again it was kind of a similar passing-based study where we were looking kind of what are the differences here. And by actually developing an expected threat model, we were able to see a really clear difference. So what you can do, or the way that this model worked, is you kind of break the pitch down into lots of little grids. You kind of essentially have a kind of Markov chain of transitions between those grids. you work out the probability of, if you've got the ball in a particular space, what's the probability you score in the next possession or the next 20 seconds or however you want to segment your data. And then, by kind of comparing the start and end locations of all of the passes that players were attempting, it really stood out that in the women's game, at least in the data that we had, all of the passes, well, not all of the passes, but the average expected threat of a pass was much higher than in the men's game. And so it was really kind of, there were a lot more passes in the men's game, but like the total threat generated was the same. And so you got this kind of, you were seeing this much more kind of dynamic, much more attacking intent behind the play.
Yeah, okay. That's super cool. And the fact that you can, does that help? The fact that you can do the same analysis on different teams from the same club, so like women academy, first men's team, etc.
Yeah, it's a really, I think it just means you can do a lot more as a data team, right? Like, I think it is important to kind of be aware of the differences between the different kind of, the women's game, the men's game, and the youth game, I guess, would be the three categories. But a lot of the models, if you write a model for the men's team, say, and then apply it to the youth team, it will certainly at least still have some validity, even if the parameters that you've trained or the exact form that you've used isn't completely optimal. And so that means that kind of when we write our post-match reports at Como for the first team, we're also able to produce the same report for the under-19s, for the under-17s. And so we're able to kind of not only kind of give the coaches more information about how their team might be doing and how we can improve, which is obviously a hugely valuable thing, but also get the players themselves really involved in the data analysis process. So they're used to playing a game and then looking at the feedback from it. And that's something you can build up a culture in the club as players are coming through. That can then kind of really just become a really natural thing as players progress into the first team. Rather than being in the under-19s, suddenly moving to the first team and then, oh no, someone's showing you a whole load of graphs about how bad you were. It's something that you can be a bit more used to.
No, for sure. And that makes also the players, like, participate in the analysis and like be part of the models and so on. I think that's much easier than to get their acceptation of what the model is saying afterwards.
Yeah, exactly.
Yeah. And are there any statistical techniques or models that you find most useful in your work? And how do you see them helping in decision making?
Yeah, so I'm a big fan of kind of relatively heuristic-based parametric models. So if I'm approached with a problem in football, particularly in a kind of prediction sense, I think kind of exploring the data and exploring kind of what you might expect to see from it, and then coming up with a model with relatively small numbers of parameters is something I find really helpful. So for example, like a lot of statistics in football, because they're count statistics over a sufficiently long amount of time, you'd expect them to be approximately normally distributed if they came over a season. And so you can bake that into your model already, which I think is a real advantage to kind of, compared to just training a completely black box model where it's got to work out its confidence intervals or prediction intervals or credible intervals or whatever it might purport to do at the end of it. Because you know that there should already be quite a lot of structure to your data. So one thing, we were building a model the other day that kind of, we were looking at the total number of actions that a player performed, like just as a simple test case for something. We allowed it to be normally distributed with any variance, and then lo and behold, after training the model, the variance parameter had a very tiny confidence interval around the Poisson mean that you'd expect to see. So it was just variance was equal to the mean. And that did make me feel slightly stupid because I was like, come on, Matt, we maybe could have seen that coming, could have saved ourselves a bit of compute there. But really taking advantage of the structure in the data and the kind of, particularly when you're looking at averages, the normal things that you'd expect to see, that can be really helpful.
Okay, yeah, that's interesting. And basically these kind of heuristics help you having some already good first results to then have a back and forth with the domain experts.
Exactly, and like it gives you a really good starting point for models. So if if you're doing something like predicting results, like as much as it's not a perfect model, starting with both teams score a Poisson distributed number of goals, like that gives you a really sensible starting point where you can add different things in. So maybe you adjust, you kind of use a Poisson, but you have some adjustment parameter to it. People use things like the Weibull distribution or something like that. Maybe, you introduce some kind of dependence in your model that once the first goal is scored, the parameters change or something as one team becomes more defensive. But having that kind of solid baseline not only gives you a good baseline to compare your other models against, but also, allows you to do this kind of slow, iterative process that gets you towards a kind of, your model at the end might be quite complicated, but because it started from a sensible point, you kind of know what all the steps were. And it also makes things really explainable. Like, that's another real advantage of these parametric models. If every one of your parameters has some meaning in your head, then you're going to be able to really easily explain that to the coaches. Whereas, I'm not sure they're going to love looking at a Sharp plot or something like that from your set of 2,000 features.
No, for sure. And that's why I think it ties back to what we were saying, where knowing how they are going to use the model is extremely important, because then you can just compute back the particular samples of your model. Instead of showing these, you just compute back to the metric they are interested in. And that gives you a lot of buy-in and also a lot of very useful back and forth, because usually they have an extremely deep domain knowledge that you don't have. And that's absolutely super valuable for you as the modeler.
Exactly, and it gives them the opportunity to change some of the parameters as well. Like if all of your inputs are things that they understand, then maybe when they're recruiting for a particular role, it's not just a winger, it's a like inverted winger that they're looking for. Then they'll be able to know, oh, this is actually more important, this is a bit less important. I can tweak those on whatever app that you've coded for me, and then see how that affects the list of players that comes up.
Right. Yeah. Very good point. Super cool. And something else I'm wondering is, you touched a bit on that already, but data is becoming more and more available in football in particular, especially tracking data. How has that influenced your work, and what new insight were you already able to provide?
Yeah, so tracking data is a really exciting data source. The fact that it's so available now is just mental. It still blows my mind that every weekend we get XY tracking data from hundreds of matches across Europe and the world. In fact, I think we get it from the States at least. And kind of in some sense the possibilities from that are endless, right? Like you've got enough data modulo the noise that's there, and it's relatively substantial. But you've got enough data to completely understand what's going on the football pitch. And so you can start to do things like I was saying earlier about the expected passes model. You can start to do things like really accurately say, oh, okay, in this scenario, these were your options. This guy you shouldn't have passed to, or you could have looked for this other option. And I think kind of, ultimately the aim of a lot of models and their kind of pieces in this very long journey is to essentially come up with a system that can play football, right? That understands the game and that is able to go, oh, okay, from this position, if I was all 11 players, I would move like this and I would pass like this, and this would kind of, increase my chances of scoring a goal by 5% or what have you. So kind of almost building, like a stockfish, but for football, which is an incredibly complicated thing to do because your players can no longer just move 2 steps forward and 1 step to the left. But I think it's the first stage. The data is there now to be able to build those models. And kind of I do see that kind of a lot of our projects that we're working towards are just ultimately you could construe them as just small pieces on this journey. And I think particularly the data that's coming out in football now as well, with not just player positions, but you get like 20 coordinates per player. You get kind of where all of their hands and their arms and their knees are. Exactly how you choose that data, I'm not entirely sure, but it's certainly an exciting thing to have.
Yeah, Definitely. And how do you see the field and the role of analytics in football evolving in the next few years?
Yeah, I mean, the very boring answer is that I think it would just continue to become increasingly important. I think we're starting to see that we've got a generation of coaches coming through who are, have been essentially had this data available to them throughout their entire coaching career, and are going to be much more willing to use it, are going to see it as a much higher priority, invest more in their data teams, and kind of, begin to use it for a lot more of their decision making. I think in terms of kind of actual things that might tangibly change, I don't think it will be too long before we start seeing, and in some sense you could argue that teams like Man City are already doing this, we start seeing strategies being employed that are kind of purely have purely been developed from the data. So rather than kind of, like I was saying earlier, using the data to decide between 3 possible lineups or something, or 3 possible formations you could play, like actually starting to build models to, say, oh, well, maybe if we get our players to kind of be in this formation and then morph into this one, like when a certain thing happens, then that's going to be really effective. And so I think, like already now, if you compare how football's played to 40 years ago, it looks very different. And I think the speed of that change is only going to be increased by data as teams kind of come up with increasingly good ways to play against each other, and the optimal strategy shifts and shifts and shifts. I think also like player recruitment from kind of like countries that don't have big leagues in is also going to increase. You already look at Brighton and Brentford are the 2 canonical examples of that, and how well they're doing. It's something that every recruitment team around the world and every kind of consultant is trying to do as well. But I think people are going to get increasingly good at that. And so I imagine you'll start seeing players move earlier because after 500 minutes with tracking data, you're able to assess that they're going to be good enough to play in the Premier League. And also kind of move to a wider range of clubs. It won't just be Brighton who sign 20 youngsters from South America who all are somehow amazing. It'll be kind of 20 Premier League clubs, each finding one youngster and then fighting over them.
Yeah. Great point. And so, like, bearing that in mind, what advice would you give to aspiring football analysts or data scientists who want to break into the sports analytics industry?
Yeah, I guess the main thing I would say to them is to kind of take the time to be curious. There's quite a lot of good open source data out there. So StatsBomb have an open data repository. They're one of the big football data providers. If you just Google StatsBomb open data, I'm sure it will come up. Skill Corner, who are one of the big tracking providers, have I think 7 or 8 example games out there, which is enough to kind of get you started playing with that. And I think just kind of take the time to have fun with that data, look at it, try and come up with some interesting models, maybe take half a season's worth of data and try and predict a certain thing in the second half. Because when clubs are recruiting analysts, like the top thing they want to see is kind of that portfolio, is that you can do things and kind of, not only have you got the interest, but you've also got the skill to be able to produce really insightful things. And so, that's definitely something that's worth doing, kind of, even if it's not connected to a club at first, even if it's just kind of in your own time. That is great for building skills. And then secondly is to try and get involved in a club. Like, I'm very, very grateful to Oxford City for kind of taking me on when I didn't really know anything. And those first couple of years of getting experience were really, really important. And they meant that when I went to slightly bigger clubs, who if I went and I was rubbish, they'd just sack me. When I went to those clubs, I at least kind of roughly knew what I was talking about and was able to do some vaguely useful things. Kind of reaching out, even if they're a club that doesn't have much data, in some sense that makes you be more creative. Like, I spent a bit of time investigating, can we build a recruitment model based on Twitter at Oxford City? Because in the 7th tier, that's basically all you've got. And it didn't really go anywhere in the end, sadly. But I'm sure someone could do a better job than me. It gives you that chance to be creative and helps you also have a real impact on the team.
Yeah, I love that. The obstacle is the way, right?
Exactly.
Yeah, I love that. That's great. Great advice. And I completely second everything you just said. And also starting being involved in some open source work is definitely a good way to get there for sure. Like trying to identify things people are interested in and you are interested in and are able to do it because, you know, you have to do it. Even if nobody is paying you to do that. You won't do that all the time, you know, all your life. But if you have some time, especially if you're in your 20s, that's when you want to experiment and do that kind of stuff. So, yeah, definitely try and do that. And as you were saying, try and finding some mentors is something extremely important. But there is a skill in doing that too, right? Like, don't go and ask people, hey, can you be my mentor? It's usually better if you have something to offer in return. Right? Like if they have a pain point and you can help them with that, then in exchange they'll be your mentor. Or
exactly,
if you contribute to their open source project or something like that, they'll be much more open to mentoring you.
Yeah.
And personally, I'm curious what your future projects or research areas are for the coming month that you are excited about.
Yeah, so I think kind of one thing that I'm really excited about looking towards working on is, kind of, again, it's a step in the journey towards this kind of chess computer dream for football. Is coming up with a really good way of assessing kind of what's the probability of you scoring a goal in the next 20 seconds from being able to use all of the contextual data you've got in tracking data. And so, like I said, like I was talking about earlier, you can make a kind of simple expected threat model, and you can kind of do a few more things along that line. I've read papers where kind of they've built graph neural networks to predict the next event in a set of event data, and you can start doing that, and you can kind of chain your predictions together and do things with the discrete data. But really moving that onto the tracking data, I think that's something that would unlock quite a lot more analysis. One of the big issues with event data is it's very much focused on the ball, and you don't get to see the case where someone makes a great run that kind of opens up the chance for a goal. You just see the player who had the ball being able to dribble into this miraculously free space and then take their shot. And so, doing that to be able to really start to get some more understanding on how the whole football team contributes to creating a chance, both offensively and defensively as well. And then I think also just continuing kind of working with coaching staff, just getting better at kind of the match analysis side of things, like learning how to really characterize opposition teams in a way that's helpful, and just kind of it's very much a learning experience. I still feel I'm in the stage where certainly if you put me in charge of a football team and like asked me to actually design a set of tactics, I would be so useless. I'd be like 4-4-2, let's just lop it up to the big guy. And so kind of continuing on that journey of learning, properly learning football is something I'm really excited to do.
So I think we can call it a show. That was like, I have so many more questions still, but I've already taken quite a lot of time from you. So thank you so much, Matt. As usual, though, I'll ask you the last two questions I ask every guest at the end of the show. First one, if you had unlimited time and resources, which problem would you try to solve?
Yeah, I guess this kind of goes back to the nerdy 15-year-old guy reading about unsolved maths problems that I was. But I would love to really get my teeth into kind of one of these like essentially impossible problems. I think the collapse conjecture has always really stood out to me as something that you just feel like you should be able to solve, but at the same time it's just completely impossible and I have no idea where to start. And so I think in an alternate life I can see myself kind of locking myself in a room and working on it for a year and probably getting nowhere, but having quite a lot of fun along the way. But yes, I feel I should maybe have said something more useful, like that would have an impact on the world. But that's just too tempting. Yeah, so I spent a long time thinking about this question. I think actually, what I'm always amazed by is kind of inventions that could have been invented quite a long time before. So something like the smartphone, right? Like an ancient Egyptian is never going to be able to invent the smartphone because they need so many different things and so many components to get there. Something like the hot air balloon, however, and so this is my answer, it's the Montgolfier brothers who invented the hot air balloon. All you need is a way of making air hot and a balloon to hold it in, and then you can fly, which is so cool, and something that like humans surely have always wanted to do. And so, yeah, like I feel like that's an idea that could have been invented thousands of years before. And so being able to sit down with those kind of guys and be like, what's your second best idea? And let me have it, so that I can invent something that wouldn't have been invented for another 3,000 years still. I think that would be great to pick their brains. I'm glad I got a unique one. Excellent. We'll fly over in our hot air balloon and then we can meet you.
Awesome. Yeah, that's great. Yeah. So hot air balloon. If you ever go to my native region, which is the Loire Valley, so in the center of France, which is the region where the castles are from the Middle Ages and the Renaissance, definitely recommend doing a hot air balloon flight. They usually start very, very early in the morning, something like 4 or 5 a.m. But it's absolutely amazing because you get to see the sunrise, and then you have like that gorgeous view of the castles along the Loire, which is the river. Yeah, that's absolutely incredible. I haven't done it myself. I speak like I had, but I watched a lot of videos of my parents because that's a present. That's the gift I made to my father for his last birthday. And yeah, like this looks absolutely incredible. So definitely recommend it. It's pricey, but it's really worth it.
Nice.
I hope you enjoyed it. A link to your website in the show notes for those who want to dig deeper. Thank you again, Matt, for taking the time and being on this show.
Wonderful. Thanks so much. It's been great.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher, and visit learnbaystats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbaystats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbaystats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.